Okay, so we'll discuss some more numericals on refractive index. Refractive index. So what is the refractive index formula? I told you refractive index is equal to sine I by sine R. I told, or refractive index is equal to velocity of light in A by refractive index of any medium is equal to velocity of light in A by velocity of light in given medium, or wavelength of light in A by wavelength of in given medium. This is also another formula for refractive index. Based on these two formulas, we do some numericals. First numerical. If angle of incidence is equal to 30 degrees, angle of refraction is equal to 45 degrees, what is refractive index? Angle of incidence is 30 degrees, angle of refraction is 45 degrees. What is refractive index? Directly, refractive index of that medium. What is the formula, children? mu is equal to sin A by sin R. So mu is equal to sin 30 by sin 45. So mu is equal to 1 by 2 by 1 by root 2 will go here. So mu is equal to root 2 by 2, children. So mu is equal to 1.414 by 2. So mu is equal to 0.707. No units for refractive index. So refractive index of this medium where light is traveling is 0.707. Refractive index of that medium. Okay, of course 0.707 won't be there, but just here it's only for practice and prediction. Second, if angle of incidence is 60 degrees, angle of refraction is 45 degrees. Find refractive index. Find refractive index of that medium. Find refractive index of that medium. How do you do, children? Mu is equal to sin 60. Snell's law. Stay there. Ratio of sine of angle of incidence to sine of angle of refraction is constant. Sin 45. So mu is equal to what is sin 60, children? Root 3 by 2. What is sin 45? 1 by root 2. This goes here, this goes here. Mu is equal to, okay, what is mu is equal to? Root 2 into root 3 is root 6 by 2. Okay, so whatever value you get, that is the answer. That is the answer. So refractive index. Next. So, children, refractive index of medium we find out if velocity of light in that medium. Let us say refractive index of benzene we find out if velocity of light in benzene is 1.2 into 10 to the power of 8 meters per second. We have to find out what is the refractive index of benzene if velocity of light in benzene is 1.2. So, children, refractive index of benzene formula. Velocity of light in A by velocity of light in benzene. So refractive index of benzene is equal to velocity of light in benzene is constant, children. 3 into 10 to the power of 8. Velocity of light in benzene is 1.2 to 10 to the power of 8. Then this cancels. So refractive index of benzene is 3 by 1.2. That is okay. How much is that? If you remove this point, what is it? 0, 2 15s, 2 6, 3 5s, 3 2s. So 2 12 2s. Okay, so 2.5. Refractive index of benzene is 5 by 2 means 2.5. That is refractive index of benzene. Okay, same some one more I will give you an example. Try to tell you. What is the refractive index of water? The velocity of light in water is 1.5 into 10 to the power of 8. Anyone wants to say girls? Same question. Refractive index of water is velocity of light in air by velocity of light in water. So refractive index of water is 3 into 10 to the power of 8 by this value absorption 1.5 into 10 to the power of 8. This cancel. Refractive index of water is 3 by 1.5 is 2. So refractive index of water is 2. Same like this only one more scenario. People are not understanding. So refractive index of glass, we should find the velocity of light in glass is suppose 1.8 into 10 to the power of 8 meters per second. If suppose. Okay. What is the formula? Refractive index of glass is velocity of light in air by velocity of light in glass. Refractive index of glass is 3 into 10 to the power of 8 by 1.8 into 10 to the power of 8. This gone. Refractive index of glass, if you remove this point, 30 will come. So 3 10s, 3 6s, 5 2s, 5 3s, so 5 sorry. 2 5s, 2 3s, so 1.67 is the refractive index of glass. Suppose we didn't understand. One more. What is the refractive index of diamond? If velocity of light in diamond is 2.14, 2.4 into 10 to the power of 8 meters per second. 1.2 by 2, 1.1. Suppose velocity of light in diamond is 1.3. So what is the refractive index of diamond formula? Velocity of light in A by velocity of light in diamond. Velocity of light in A is 3 into 10 to the power of 8. Velocity of light in diamond is 1.3 into 10 to the power of 8. This is from, so 30 by 30, that is 2, 26, 40, 2.3 approximately. The refractive index of diamond is 2. Same sums, children, I'm saying again and again, same sums. I think one more numerical. So one more numerical for you to understand. I hope you people please go. Okay. Children, question is like this. Velocity of light in air is 3 into 10 to the power of 8. Okay. So velocity of light in water is 1.5 into 10 to the power of 8. The wavelength of light in air is approximately 6 angstrom units. What is the wavelength of light in water? That's the question. Okay, Shida? So already here I have given one relation. You can see children. Here I have given one relation. What is that relation? Refractive index of medium is velocity of light in air by velocity of light in medium, or wavelength of light in air by wavelength of light in medium. Here, since I spoke about air and water, let's talk about air and water. Velocity of light in air by velocity of light in water is equal to wavelength of light in air by wavelength of light in water. Now, do you have the formula? Let's substitute. This value is this value, 3 into 10 to the power of 8. And this value they have given 1.5 to the power of 8. I'm sorry. Wavelength of light in air is 6 angstrom units. 6 angstrom units. What is the wavelength of light in water? This is the question. This gone. This is 2. So 2 is equal to 6 by wavelength. This goes up, this comes down. So wavelength of light in water is 6 by 2. Wavelength of light in water is 3 angstrom units. Angstrom means 3 into 10 to the power of minus 10 meters if you want. This is how we do it. No, sir, we didn't understand this. One more summation. Please try to concentrate. If you concentrate only, you will understand children. Nothing is there, not a rocket science. This is very, very easy question there. Okay, one more question. Like this only. I'm saying, isn't it? Okay, so what is velocity of light in air is 3 into 10 to the power of 8 you all know. Okay, find the velocity of light in glass. If refractive index of light in air is 3 angstrom units, and let us put that 6, and refractive index of light in glass is 9 angstrom units. Like this. Same children, same. Okay, what is the question? See here, see here, see here. Velocity of light in air by velocity of light in glass is equal to wavelength of light in air by wavelength of light in glass. Substitute the values here. On substituting the values, velocity of light in air is how much? 3 into 10 to the power of 8. Velocity of light in glass. Wavelength of light in air is 6. Wavelength of light in glass is 9. Okay, this goes here, this goes here. So 3 into 10 to the power of 8 into 9 is equal to 6 into velocity of light in glass. 6 will go down. Velocity of light in glass is 3 into 10 to the power of 8 into 9 by 6. So 3 to the velocity of light in glass is 9 into 10 to the power of 8 by 2. Velocity of light in glass is 9 by 2 is 4.5. 4.5 into 10 to the power of 8 meters per second. Like this. Okay, this is all refractive index questions. One more time, I need to understand clearly. So refractive index of some object, some medium is 1.3. And what is velocity of light in that medium? Question. Refractive index of some medium is 4.33. What is the velocity of light in that medium? So children, can anyone say what is 1.33 value? Anyone? 1.33 we can write as 4 by 3 children. Easy to calculate. 1.33 is 4 by 3. Okay, so refractive index of medium is velocity of light in air by velocity of light in given medium. Refractive index of medium is given as 4 by 3. Velocity of light in air is 3 to 10 to the power of 8. What is the velocity of light in medium? Cross multiplication. This here, this here. So velocity of light in medium is 9 into 10 to the power of 8 by 4. So velocity of light in that medium is 2.25 into 10 to the power of 8 meters per second. Like this. Suppose you didn't understand. One more question. Refractive index of certain object is 2.4. What is the certain of the certain medium? What is the velocity of light in that medium? This is the question. Refractive index of some medium is 2.14. What is the velocity of light in that medium? Vasha, can you tell how to say like this one? Satvika, can you tell this? Alekia, can you tell this?
Sir, it will be by VA by VM.
Velocity of light in A by? Velocity of light in? Say. Asking you people to raise. Okay, don't touch it. I will not. So 3 into 10 to the power of 8 by velocity of light in medium. This goes here, this comes down. Velocity of light in medium is 3 into 10 to the power of 8 by 2.4. Okay, so velocity of light in medium is, if you remove this point 1, 0 will come up 30 into 10 to the power of 8 by 24. 3 tens are 3 eights are, okay, 2 fives are 2 fours are. So velocity of light in that medium is 1.25 into 10 to the power of 8 meters per second. I know you people didn't understand. One more I will say. Refractive index of some medium, let us take it as 1.5. Find the velocity of light in that medium. That's it. Okay, so what we will do is velocity of light in any medium is velocity of light in A by given medium. If it is glass, glass. If it is water, water. If it is diamond, diamond. This is constant always. So this is given as 1.5 into 3 into 10 to the power of 8 by velocity of light in medium. Okay, so velocity of light in medium is 3 into 10 to the power of 8 by 1.5. Velocity of light in medium is 2 into 10 to the power of 8 meters per second in that medium. Okay, one more question. Refractive index of some medium is given as 1.8. Okay, find the velocity of light in that medium. Find the velocity of light in that medium. So same question. Refractive index of any medium is velocity of light in A by velocity of light in given medium. So this is 1.8. Velocity of light in A is 3 into 10 to the power of 8 by velocity of light in given that medium. This medium. Okay, this goes up, this comes down. Velocity of light in that medium is equal to 3 into 10 to the power of 8 by 1.8. That is, point will go up. So point it goes up. 30 into 10 to the power of 8 by 18. 3 tens are 3 sixes are 2 fives are 2 threes are. So velocity of light in that medium is 1.6 into 10 to the power of 8 meters per second. Same question. Same question. Another formula we have V is equal to F lambda, where F is the frequency, V is the velocity, lambda is the wavelength. They will say, children, suppose find the frequency of light in air whose wavelength is 6 angstrom units. 6 angstrom units. That's it. So what will the children? We know V is equal to F into lambda. V, velocity of light in air is constant, that we should never forget. And frequency we should find out 6 angstrom units. 6 angstrom. 6 will go down. Frequency is equal to 3 into 10 to the power of 8 by 6 into 10 to the power of minus 10. Okay, this is 1 by 2. 1 by 2 is 0.5 into 10 to the power of 18. Okay, if we remove this point, children, so frequency is 5 into 10 to the power of 17 hertz is the frequency of that light which I gave. This light, whose wavelength is 6 angstroms. Okay, next. Next one more question, same as this one. Okay, find the frequency. Find the frequency of light whose wavelength is 10 angstroms. Okay, second question. Find the wavelength whose frequency is 2 hertz. Third question. Find the velocity whose frequency is 2 hertz and velocity wavelength is 8 angstroms. Same questions, all the same questions. Only thing is I'm changing the subjects. We know the formula is everywhere V is equal to F lambda, V is equal to F lambda, V is equal to F lambda, velocity of light. Velocity of light in A, suppose if nothing is given, take velocity of light in A. 3 into 10 to the power of 8, frequency want 10 angstroms. 10 angstroms is 10 into 10 to the power of minus 10. Okay, children. So this goes down. So frequency is equal to 3 into 10 to the power of 8 by 10 into 10 to the power of minus 10. Okay, children. So frequency is equal to 3 into 10 to the power of 8 by 10 to the power of minus 9. This goes frequency is equal to 3 into 10 to the power of 17 hertz. 3 into 10 to the power of 17 hertz. Right here, same. So B is equal to 3 into 10 to the power of 8, 2 hertz, find the wavelength. So we take 2 down, children. So lambda is equal to 3 by 2 into 10 to the power of 8. So lambda is equal to 1.5 into 10 to the power of 8 centimeters or meters or what? Meters. Meters. Okay, children. Next, this one. B is equal to F lambda. B is equal to frequency is how much? 2 hertz. Lambda is 8 angstrom. 8 angstrom is 10 to the power of minus 10. Angstrom is 10 to the power of minus 10. So speed is 16 into 10 to the power of minus 10 meters per second. Is very slow. Actually, I just tell you a question, a little bit long question. We will take 2 into 10 to the power of 10 will take hertz. If you take like that, you take 2 into 10 to the power of 10 hertz. So what it will become? So what it will become? Children, frequency is how much? 2 into 10 to the power of 10, and wavelength is how much? 8 into 10 to the power of minus 10. It is done 16 meters per second. 16 meters per second. Next, 1 second. 1 second. Next question. So they are asking figures. Here question they are asking. First question. First question they are asking me. What do you understand by refraction? Yesterday I told refraction means what? Refraction is the bending of light when it enters from one medium to another medium. What is refraction? Bending of light when it enters from one medium to another medium. Why it bends when it enters from one medium to another medium? Due to change in the velocity of light. Due to change in the velocity of light, light bends when it enters from one medium to another medium. Bending of light is called refraction. When it goes to other medium only, it will bend. In the same medium, it won't bend. Okay, second question. Second question. Draw a diagram to show the refraction of light from air to glass, glass to air. Air to glass and glass to air. Children, suppose this is air. This is glass. Air is rarer medium. Glass is denser compared to air. Compared to air. Okay. So this is glass. So exterior light one, rarer to denser, always light moves towards the normal. Rarer to denser, light will moves towards the normal. So this is light ray. It moves towards the normal. Light is towards the normal. And it's also asking glass to air. Glass to air. So children, this is glass. This is air. Air is rarer medium. Glass is denser medium. This is refractive index. Children, denser to rarer, it moves away from the normal. You all know that. Whenever light moves from denser to rarer, it moves away from the normal. Away from the normal. It goes away from the normal. So rarer to denser means comes towards the normal. Denser to rarer, it goes away. The angle of incidence is angular. Angle of refraction is angular. The angle of incidence is angular. Angle of refraction is angular. Like this. So glass is comparative to air is denser medium. So like that you should imagine. Next third question. They have given a ray of light in incidentally normal and glass hair. What will be the angle of refraction and what is the angle of deviation for the ray? Okay. So children is asking plain glass hair. Plain glass hair means like this. Plain glass hair. Okay, plain glass hair. So plain glass hair means like this. The light ray is incidentally normally. Normally means like this. Okay. Question is what will be the angle of refraction and angle of deviation for the ray? So children, see here light ray is coming like this. Okay, normally children try to understand. Normally, if light ray is coming like this, here we will draw normal and this will be the angle of incidence. But this ray has come like this. Then what is the angle between incident ray and normal? What is the angle? Here only normal is there, here only incident ray is there. So what is the angle of incidence? Angle of incidence is 0 degrees because here only angle of incidence is there, here only normal is there. So because it is falling normally, it will not deviate. It will go straight like that only. It will not deviate. So angle of reflection also 0 degrees and angle of emergence also 0 degrees because it is not falling at an angle, it is falling at 90 degrees, it will go very directly without deviating. If it falls at some angle only, then rarer to denser towards the normal it will bend, denser to rarer it goes away from the normal, all these things happen. If it is falling normally, then it will go straight without deviation. So 0 degrees is the angle of incidence and angle of refraction. 0 degrees is the angle of incidence and angle of refraction. Next question. What is the cause of refraction? Question. What is the cause of refraction? Changing speed of light. Changing speed because when it is suppose it is entering from air to glass. In air it goes at 3 to 10 to the power of 8, but in glass it will go at 2 to 10 to the power of 8. Due to sudden change in the speed, bending occurs. Due to sudden change in the speed when it enters from one medium to another medium, bending occurs. What is the cause of refraction? Change in the speed. What is the cause of refraction? Change in the speed. Okay, different medium, different speed. The light suffers reflection and refraction on the boundary passing from A to 1. Draw a neat label diagram to show you. So children, suppose this is air and this is water. Is asking, is saying that some light will undergo reflection, some light will undergo refraction. Show both of them the same. Show both of them the same. Okay, let us draw normal. Let us draw normal. Now some angle of incidence. This is angle of incidence. Okay, this is rarer medium. This is denser medium. Rarer to denser moves towards. This is angle of refraction. This is refractive. Some light rays will undergo reflection. If reflection is it will go like this. In reflection, angle of incidence will be equal to angle of reflection. Okay, this is refraction, this is reflection. This is reflection and this is refraction. Refraction occurs only if it changes the medium. Reflection occurs in the same medium. Okay, reflection occurs in the same medium. Reflection occurs in the another medium. One more question I'm going for this. 10 questions and then I'll show. A light ray suffers, okay, a ray of light passes from one medium to another medium. Okay, so when a light ray is going from one medium to another medium, what will change is velocity will change, wavelength will change, intensity will change, but frequency always remains constant. How many mediums also it is changing? Frequency always remains constant. Frequency will never change. Next question, eighth question is 8, 7. What is Snell's law? What is Snell's law? Snell's law states that ratio of sine of angle of incidence to sine of angle of refraction is constant, called as refractive index of medium. What is Snell's law? Ratio of sine of angle of incidence to sine of angle of refraction is constant. What is Snell's law? Ratio of sine of angle of incidence to sine of angle of refraction is constant. That is called Snell's law. Eighth question. Define the term refractive index of medium can it be less than 1. Refractive index is velocity of light in given by velocity of light in given medium. Can it be less than 1? No, it can never be less than 1. Refractive index can be constant because speed of light in air is 3 to 10 to the power of 8. No one can travel on the earth with the speed of light. Maximum is speed of light. That's why refractive index will be 1 or more than 1, but it can be never less than 1. It can be never less than 1 because no one can travel with more than speed of light. So never refractive index will be less than 1. Okay, so it will be always more than 1. Okay, next one. Ninth question. Okay, ninth question says that compare the speeds of light of wavelength. One wavelength is 4,000 angstroms of violet light, and wavelength of red light is 8,000 angstrom units. Compare the speeds of the light. Compare the speeds of the light. Okay, so children, all lights travel with Same speed in A. All light travels with same speed in A. Song is 1:1. All lights travel with same speed, no need to find. How is the refractive index of medium related to the speed of light? Refractive index is equal to velocity of light in air by velocity of light in medium. How it is related? Refractive index is inversely proportional to speed. If refractive index is more, speed will be less. Like example, air is there, water is there, glass is there. In which of them light will go very fast? Air. Next, water. Because water and glass, refractive index of water is less than thermo. So next is water, then least is glass. If refractive index is more, speed of light will be less. If refractive index is more, speed of light will be less. Last question. Remaining questions are in the next question. A light passes from water to air and glass. In case, how does the speed of light change? Children, see, this is water. This is water. Okay. In this case, light is going into air. In this case, light is going into glass. If light is going from water to air, more dense to less dense, speed increases because air is less dense. Whereas here, glass is more denser. Glass is more denser than water. Here, speed of light decreases. Why? Because glass is more denser than water. Here, air is less denser. That's why here speed increases. Here speed decreases. Like this, we'll do some more questions if you are interested tomorrow.
No, sir, that's